All right, so this is 7-3, and the biggest thing that we're going to start off learning is that the ordered pairs that I ask you to know, when someone asks you for the cosine of theta, that is equivalent to the x coordinate. And if someone asks you for the sine of theta, that is equivalent to the y. So to give you an example, if I said the cosine of 30 degrees, what you would do is you would look at your unit circle. You go, okay, 30 degrees is right here. And if you look at 30 degrees, your coordinates for that should be square root of 3 over 2 and 1/2. And since they're in this quadrant, I know that the x is positive and the y is positive, so I don't want to think about that. So I know that this is the cosine is the x. So this would be equivalent to the square root of 3 over 2. Now, if you put this in a calculator, you're going to get a long decimal. So if you actually put that in a calculator, cosine of 30, it's going to equal 0.866025, which they don't want that answer. They want this one because this one is rounded, right? This is the exact answer. And actually, if you take the square root of 3 and divide it by 2, you get this same decimal. But we don't want it as decimals. We want it as that fraction right there. So that's why I asked you to memorize the unit circle last time, because you are going to use that in place of when someone asks you what the cosine of 30 is, you're going to be able to put that. Cosine matches up with the x from the order pair. Sine matches up with the y. So if someone asked you for the sine of 30 degrees, you would say that it's equal to 1/2. This is also the same thing, just like we talked about. There's different ways. This is called in degrees. If someone asked you for the sine of pi over 6, if someone said, what's the sine of pi over 6? Well, sine is still the y, and pi over 6 is still the same thing as the 30. So it's still going to be the y of this coordinate. So it'd be 1/2. All of these, this right here, this, and this. Oh, not that, sorry. Sine of 30, sine of pi over 6, and 1/2. Those are all the same thing. That's what it means when they are equal to each other. Now, if you actually took a calculator and you hit, like I said, this would pop up. If you took a calculator and did this would pop up. However, if you tried to do the cosine of pi over 6, it would not work because your calculator is in degrees. So what you actually have to do on a scientific calculator, there's a thing that you can change your mode, and you actually have to change your mode to rad. It'll say radians or rad or something. You have to change your calculator to radians, and then you would be able to put this in. And if you put this in your calculator in radians mode, and you put this in your calculator, this number would pop up. If it's not in radians, it would be like 0.99995 or something. And that would be the wrong one. That's because it would actually be doing pi over 6 degrees, which is not what we want. When we do pi over 6, we're talking radians. So you got to make sure you change your calculator mode. Does that first part make sense for you? Give me a thumbs up if that makes sense, please.
Weren't we supposed to have our test today?
Yep, this is your test. This is what we're talking about. We're going to be using the unit circle all through 7-3. So any questions on that? All right. So here is one for you to try on your own. Let's say I asked you for, what is the cosine of 4 pi over 3? And what is the sine of 3 pi over 4? Please get those two answers for me.
Are we doing these problems right now, or is this the test?
Yeah, you're doing them on your own.
Okay.
Mhm. Well, if you notice, the ones that I ask you right now are all going to be the ones that are on the unit circle. Both of these are on the unit circle. Let's tackle this one. As soon as I see cosine, I realize that they're asking me about the x coordinate. So I'm going to think x. Okay, I need the x. I need the x of the 4 pi over 3. Well, when I look at the unit circle, the 4 pi over 3 is in this location. That's where the 4 pi over 3 was. And if I look on the unit circle, or if I have it memorized like I'm supposed to, I should know that in this one, that is the 1/2 and the square root of 3 over 2. And since it's in quadrant 3, I know both of them are negative. So if they asked me for the cosine, which is the x, this should equal a negative 1/2. That should be your answer for that one. Did anyone get that? Give me a thumbs up if you got that. Good, quite a few of you are getting it. All right, if you want to do the sine of this one, as soon as I see sine, I know that they're asking me for the y coordinate of that coordinate. So I go on my unit circle, 3 pi over 4, that's going to happen up here. And the 3 pi over 4 is going to be a 1/2 square root of 3 over 2. And I know it's going to be a negative x and a positive y, because anything in this quadrant is negative and then positive, anything in this quadrant. So since they're asking me for the y, I know that that is square root of 3 over 2 would be the answer to that question. Oh, wait, I lied. Whoops. 3 pi over 4, Mr. Martin, would be this one, the middle one. That would be 4 pi. That would be the one I just tried to do was we're counting by. That would be 2 pi over 3. Sorry about that. That's the wrong one. The 3 pi over 4 is the one associated with the 45-degree angle. So that one's going to be the square root of 2 over 2. Sorry about that. Square root of 2 over 2. And the x is going to be negative. The y would be positive. And so since they're asking for the sine of that would be the y, which is a positive square root of 2 over 2. Sorry, did anyone get that now for that answer? Does anyone have questions on what I'm talking about? All right, well, we did some of this too the other day. We talked about, well, what happens if they wanted me to do the cosine of negative 45? Well, negative 45 is not on my unit circle, but there is something that is equivalent to negative 45 on my unit circle. They are really asking me for, if they ask me for a negative 45, that would be like this direction, a negative 45. So I don't want to think of it like that. I want to think of it like this, which would be equivalent to a 315, which is again the one that has the square root of 2 over 2 as both my x's and y's. Since I'm going right and then down, I know it's positive and then negative. So I'm doing the cosine of 315. Cosine is associated with the x, so I look at this and I see the x is square root of 2 over 2. Is that making sense on how I didn't think of it as the negative 45, but I thought of it as this? We did those conversions all in 7-2. That's why it's kind of all coming together. All right, next thing we need to discuss is tangent. Tangent of theta is equal to the sine of theta divided by the cosine of theta. So like if I asked you for the tangent of 30 degrees, you would actually do the sine of 30 and divide it by the cosine of 30. So you're going to go, okay, this one is square root of 3 over 2, 1/2. The sine is the y, right? So the sine is the y, the cosine is the x. So this would turn into 1/2 divided by square root of 3 over 2. I just taught you how to find the sine. The sine is the y coordinate. The cosine is the x coordinate. So I used those two coordinates and filled them in accordingly. And then here comes algebra. We do not think of this as a fraction. We think of it as a division problem. We then say we don't like to divide by fractions, so we keep change flip. We then realize that we can cross simplify. We finally realize we are not allowed to have a square root in the denominator. And we end up with the square root of 3 over 3, and that's my final answer. How did we do on that? Questions on that? All right, so kind of keep going along with the thing we talked about. What if I have the tangent of 3 pi, which, by the way, this is the tangent of 3 pi. This you got to be careful of, right? That doesn't mean the same thing. We would do tangent of 3, then times it by pi. Totally different than 3 times pi, then the tangent, right? So this one is what I'm asking you to do. Well, if you look at your unit circle, there's no 3 pi. But what we talked about is this is pi, this is 2 pi, another rotation would be 3 pi. So what is 3 pi really equal to? 3 pi is really equal to just pi. So I'm actually going to think of this as the tangent of pi, which would equal the sine of pi divided by the cosine of pi. Well, I know this coordinate, it's a unit circle, so it's 1, so it's -1, comma 0, because I went left. Sine is the y, so it'd be 0 divided by the x, which is -1. 0 divided by -1 is 0. So the tangent of 3 pi and tangent of pi is 0. Questions on that? Thumbs up. This is what you'll be practicing tomorrow in class. An identity I need you to know. The sine squared theta plus the cosine squared theta is actually equal to 1. So my question for you is, what is sine theta if cosine theta equals -3/5 and is in quadrant 3? We'll talk about this part at the end. We'll see where this comes into play at the end. So what is sine? Well, we would just do sine squared theta plus, take out this, we'd put this in its place, but it's not just cosine of theta, it's cosine squared. So this is just cosine of theta, so we have to square it in order to keep it the same for when we plug that in. So we just square that, equals 1. When we square fractions, we just multiply top times top and bottom times bottom. So this would be just 3 times 3, which is 9, over 5 times 5, which would be 25, and a negative times a negative would kick to a positive. and that equals 1. We're trying to get theta by itself, or just sine theta by itself. So we're going to minus 9/25. Minus 9/25. We're also going to change the way that this one looks. We don't want it to be that, because in order to subtract fractions, we have to have common denominators. So we're going to change that to 25/25. This becomes sine squared theta equals 25 minus 9 is 16/25. Just like anything, to get rid of the square, we can square root it. So we square root, but we put the square root sign in. So technically, we were going to put a plus or minus. Square root of 16 is 4 over square root of 25 is 5. So it'd be plus or minus 4/5. But I noticed that this sucker is in the third quadrant. And if I think about the third quadrant, the x and the y are both negative. Well, since I'm dealing with sine, technically it kind of doesn't matter since they're both negative. But since I'm dealing with sine, the sine would be the y value. So my y value is supposed to be negative. So theta would equal negative 4/5. Sine theta, sorry. That would only get rid of the square, not rid of the sine. So sine theta would equal negative 4/5. Hit me up with the thumbs up if that makes sense. Any questions so far? All right, last idea that we need to come over is this idea that secant was the reciprocal of cosine. So that means that secant actually equals 1 over cosine of theta. So the way you're going to solve this, if I asked you for the secant of, and I keep trying to start us off because I'm not trying to trick us. If I asked you for the secant of 30, again, you're supposed to know you're supposed to memorize this unit circle. You should know the ordered pair for this one is square root of 3 over 2 and 1/2. And cosine is the x from that. So this would equal 1 over the square root of 3 over 2. Again, right here, we don't like this fraction, multiple fractions and fractions. So we go, that means 1 divided by the square root of 3 over 2. We change, we flip. 1 times 2 over the square root of 3. That would just leave that as a 1 times that would just leave it as self. So it's 2 square roots of 3. So I'm going to times it by 2, the square root of 3 over the square root of 3. 2 square roots of 3 over 3. And there's my final answer. That would be the secant of 30. And to finish them up, you would do this same kind of process for cosecant, but cosecant is the inverse of sine, so you would do the y coordinate, and cotangent of theta is equal to 1 over the tangent of theta. So cotangent's a little trickier because you'd actually have to figure out what the tangent is first, and tangent you would have to do sine of theta over cosine of theta. So you'd have to do like this problem, then take that answer, plug it into here, then deal with this problem. So like if I asked you for the cotangent of 60 degrees, you would say, okay, cotangent of 60. Well, I know my unit circle. 60 is up here. That's the one that's 1/2, comma, square root of 3 over 2. And I know that this is equal to 1 over tangent of 60. Okay, I got to take this over here and kind of figure that out on its own. So I go, okay, tangent of 60 is equal to the sine of 60 divided by the cosine of 60. You got to deal with this on its own. So I go, okay, this is really equal to, sine is the y, so square root of 3 over 2 all over 1/2. Okay, here we go. Square root of 3 over 2. I'm going to flip this by itself. So I'm going to multiply this by 2 over 1. Hope I can do that without freaking you out. Cancels out. So really the tangent of 60 is the square root of 3. So that means that this equals 1 over the square root of 3. I don't like it written like that, so I times by the square root of 3, square root of 3, square root of 3 over 3. That's the cotangent of 60. So it kind of was like a problem. And then another problem inside that problem. I had to solve this. Once I solved this, I knew this would go down into here, and then just simplify this garbage. Yes, no, maybe so, kind of. Thumbs up.